Hi and welcome back. My name is Idan, and in this section we will start zooming on the basic definition of cloud computing. Cloud computing is based on five essential characteristics. This is what you see here on the right side: on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Each one of them is an important building block for almost any cloud service and cloud solution being used today. But again, what is really cloud computing? According to the official definition of cloud computing based on the National Institute of Standard and Technology, and I'm reading right now, cloud computing is a model for enabling convenient, on demand network access to a shared pool of configurable computing resource that can be rapidly provisioned and released with minimal management effort or service provider interaction. These two sentences summarize really good the concept of cloud computing, but for anyone that is new to this concept, it is of course too high level and we need to drill into this definition. In addition, this cloud model, and I'm continuing reading, is composed of five essential characteristics, three service models, and four deployment models. And we are going to start with detailed definition of the five essential characteristics of cloud computing. Starting with the first one, on-demand self-service. What's the meaning? On-demand self-service is a major mind shift in how computing resources should be provisioned. Instead of manually contacting some cloud service provider or the IT team in some organization for allocating resources or changing specific configuration, consumers or end users will be able to perform most of the activities by themselves with minimum human interaction. And secondly, they will be able to perform it online, on demand, almost instantly. This is the key word, instantly. This is the mind shift I'm talking about. End users can decide what kind of IT resources are needed and allocate them in real time. Now, how such level of automation and flexibility is achieved? Okay, typically this is being done through some interactive web portal, enabling consumers like you and me to configure and manage services by ourselves. The cloud system itself provides some abstraction management layer, or also called automation framework, that is hiding the complex cloud details, but in parallel provide the level of flexibility to provision resources without the help of someone else, some support team. It can be from some third party service provider or even your own IT team in your organization. Basically, you don't need to call someone and wait for some few days approval and then some activation process. You can do it by yourself. Now let's review in more details the options that are available today to perform on-demand self-service. Most cloud systems that are available today will provide several methods for end users to manage by themselves the allocated virtual resources. The first very common option that we already mentioned is to use some web-based management portal with all options divided to categories in very nice way. And that will be the preferred way for most users, and it is great for specific type of activities. The second option is to use a command line console, like a shell interface, for all kind of repeated tasks that require automation and faster configuration. Basically, users are typing command, okay, and the shell interface can be used interactively, meaning we can type in the needed commands instead of performing the same activities using the web dashboard. And of course, we can use scripts and all kind of templates to make some action much more automated. The third option is to utilize and use a group of web APIs exposed by the cloud system, enabling almost complete automation directly from a software code or by some external system. Now, web APIs are usually based on REST APIs, meaning request and response over the famous HTTP protocol. The last option is SDK. SDKs stand for Self-Development Kit. This is for programmers where a specific cloud system provide some native function object classes for different language like Java, PHP, Python, and so on to access different cloud services. Okay, think about some web application that is designed from the ground up to sit on a cloud solution and directly utilize the cloud capabilities from the program code. And this is the concept of using an SDK. If I will summarize, then on-demand self-service is really a key concept in cloud computing, and all of those different options are clearly meant to automate the process and make it easy and flexible for different use cases. The second characteristics of cloud computing is called broad network access, and I think this is quite straightforward today, meaning the cloud computing services should be accessed using standard network connection from multiple locations and from a wide range of endpoint devices. We didn't touch yet the deployment options for cloud computing, and we'll get to that in more details in later section. But one very common cloud deployment option is called public cloud. In a public cloud, the cloud services are provided by a cloud service provider, and then those services must be accessed by the public from any corner around the world using the global internet. Now, another option is to use something that is called private cloud, where the cloud system is owned and managed by a specific organization. And in that case, it is expected that this system will be available from multiple locations using variety of endpoint devices. Think on your Outlook corporate email account. In most cases, you access it using your desktop, your computer, a mobile phone, or some tablet, whether you are in the office connected to the organization local area network or outside the office on a business trip. Users today are expecting to get the same connectivity and access level for all cloud services. The next important property of cloud computing is resource pooling. Resource pooling is basically the ability to use a pool of resources for multiple end users, customers, consumers. For example, here on the right side, we have a cloud system, and in the middle, a grid of resources. Now, if we will zoom inside, then we will be able to see below physical computing, storage, and networking resources. This is the green layer. On top of that, some virtualization layer. And on top of that, a cloud management platform being used to manage this complex infrastructure. Now, in this setup, virtual resources like virtual machines, can be allocated or pulled from this underlying infrastructure. Another way to visual that is by looking on the type of clients or users that are using the cloud system in a given time. We have resources in the middle of the cloud where they are managed as a pool of shared resources. Now, blue users, what you see on the left, are users that are in the process of provisioning and allocating new cloud services based on the available resources in the cloud. And green users are users that are currently using the cloud system, consuming resources. And the last type is orange users that are exiting the cloud after removing the allocated cloud-based services and the resources that will be at the end returned to the pool of shared resources to be allocated to the next user, to the next customer. This is the basic concept in cloud computing. Let's read also the official definition, the NIST definition for resource pooling. The provider's computing resources are pooled to serve multiple consumers using a multi-tenant model with different physical and virtual resources dynamically assigned and reassigned according to consumer demand. As we just saw in the previous diagram. Okay, this is what we saw. And I'm continuing reading. There is a sense of location independence in that the consumer generally has no control or knowledge over the exact location of the provided resources, but may be able to specify location at a higher level of abstraction. Okay, when we use a virtual resources being pulled automatically by the cloud system from the available pool of resource, we have limited control on where will be the actual physical hardware location of the allocated resources. In most cases, we can select maybe in high level the region and the data center location where we would like to locate our virtual resources, and that's good enough to meet specific latency availability requirement for applications sitting in the cloud. So we can use cloud services on demand and provision them by ourselves, access them using the network, and allocate specific resources from a pool of available resources. Now, to be able to provide that kind of flexibility, cloud system must support a capability that is called rapid elasticity. Rapid elasticity is the ability to quickly scale up and down services. Resources can be quickly expanded or reduced depending on demand. And if I will use the NIST cloud definition, and I'm reading right now, capabilities can be rapidly and elastically provisioned, in some cases automatically, to scale rapidly outward and inward commensurate with demand. So a key feature of cloud environment is that it provides a platform that is designed to be elastic. Users can provision resources, pay for the allocated time period, and when the resources are no longer needed, they can just release them back to the pool of resources. This brings some key values to organization, customers that using cloud computing. The first one is to avoid the cost of idle computing resources. And secondly is to quickly respond to keep changing demand. A good way to visual rapid elasticity is by using an example of application workloads. A workload is the amount of IT resources being consumed by a specific application in particular time while doing some work. Okay, this is the definition of workload. Now, IT resources can be, for example, process power, memory, storage capacity, traffic load, and other types of resources. Now, let's assume that the utilization per each IT resources that I just mentioned can be measured, okay, somehow. And those measurements can be used to increase or decrease the allocated IT resources assigned to a specific application that is creating a workload. Now, looking on the graph on the left side, static scaling. What's the meaning of static scaling? So we have three lines. The first one is predicted workload. What we predicted will be the workload for our application. The second line is experienced workload. What was the reality? How much our application was consuming at the particular time. And the last one is IT resources, the amount of resources that were allocated, okay, for our workload. Now, in static scaling, this is what you see right now in the graph, is that the IT resources are jumping and scaled up to the predicted peak workload. Okay, if we'll take simple example, if we predicted that our application will require 10 gigabytes of memory at the peak point, then the allocated memory resources will be 10 gigabytes when it's scaled up. Now, of course, there are many types of workload patterns. Some of them are constant, some of them are dynamic, they can be random or predictable, as we just saw in this example. And it really depends about how the application is being used and so on. What's the nature of the application? But if we look now on the graph on the right side, and this is what we call elastic scaling, now the allocated resources are increased slowly, okay, in small intervals according to the experienced workload, the real workload. Now, when we use elastic scaling, resources can be provisioned and removed, decommissioned much faster, with much tighter alignment between the current workload and the allocated IT resources. And this is the whole idea about rapid elasticity. Elastic scaling is usually implemented by using a feature that is called auto-scaling. If you will open some a cloud service provider, you will see a capability that is called auto-scaling. Okay, what's the idea about that? Auto-scaling is the capability that allow us to automatically add or remove instances from some cluster of instances based on increases or decreases in actual load. Okay, we can provision a specific cloud service, doesn't matter what kind of service right now, configure something that is called a scaling policy to be used as the scaling condition, and from that point of time the cloud system will start to monitor the resources related to our new service. Now, if the load is crossing some level, okay, specific resources will be scaled up to maintain the performance that we need in our workload. And if the workload on specific resources are decreasing, then the system will automatically perform downscale to minimize the cost, to minimize the amount of resources that are being actually used. The last important characteristics of cloud computing is measured service. Basically, the whole business model of cloud services is based on renting a particular service for a specific time period. Okay, and if I will use the NIST definition, and I'm reading, cloud system automatically control and optimize resource use by leveraging a metering capability at some level of abstraction appropriate to the type of service. Now, there are many types of services in the cloud and resources that can be rented on demand in parallel to multiple customers, multiple users. So in that scenario, the cloud system must measure, okay, the time a specific service was consumed and be able to bill a specific customer based on that information. It is similar to our monthly electrical bill. Okay, our power consumption at the end is monitored and measured by some utility company. So a cloud environment includes some built-in capability to track and charge customer for units of resource being consumed. Now, using the NIST definition, resource usage can be monitored, controlled, and reported, providing transparency for both the provider and consumer of the utilized service. Now, this information is also available to the consumer, so they can track their own consumption, get alerts based on configurable limits, view reports, audit the actions being performed on the system, and basically use that information to optimize their usage and at the end reduce costs. In a cloud system, the consumers that are using the system are usually pay for the measured service by some unit time, like an hour, or in some cases it can be even minutes, with no upfront payments. Okay, so we can increase or decrease the compute capacity that is needed, okay, depending on the demand. It can be manually or automatically, and only pay the specific time period a specific resource was allocated. This is also called in the market pay as you go. You pay for the resources you decided to use. Now, how cloud service providers are measuring the service is quite complex, and it will be a little bit different between each one of them. But in general, it will be measured using some consumption units, like, for example, the amount of CPU that are allocated, the memory size, the type of the operation system being used. It can be Linux, it can be Windows, location, regions, storage type and capacity, the bandwidth consumed by the application, some specific service level agreement between the provider and the customer, some support package, and so on. Now, looking on the customer perspective, at the end, the desire is to only pay for the IT resources that were actually used. And this is fully supported by the measured service capability in cloud systems.